I have titled this video, Cybersecure Software, New Twists to Well-Known Questions Every Developer Should Be Asking. But I could have alternatively titled it, What Do We Really Mean When We Say Essence Checklists Are Not Check-the-Box Checklists? And you will understand why as we get into this subject. The Department of Defense Instruction 5000.02 is the policy that directs the United States Defense Acquisition System. Enclosure 14 of that instruction addresses cybersecurity requirements, including vulnerability points for networked and standalone software-intensive systems. While the instruction was written with defense systems in mind, in today's Internet of Things world, its relevance extends to all software-intensive systems. In this short video, new cybersecurity twists to well-known questions every software developer should be asking are explained. The questions are derived from Essence, an object management group standard. Examples of how checklists from the Essence standard can be used to help software developers address cybersecurity risks and solve related problems are provided. This video should also be of interest to managers and acquisition professionals who want to know more about what software developers should be doing to address cybersecurity concerns. While the checklists and related questions to be discussed shouldn't be new to competent software professionals, a close look at many of today's cybersecurity breaches indicates root causes often trace back not to the fact that the questions weren't known or asked, but rather to the fact that they weren't asked and acted upon by the right person at the right time. And as you will learn from the examples provided in this video, the right person is often a project software developer. You might be wondering why you should care about this topic. Data security isn't just an issue that regulated environments such as the U.S. Department of Defense and the medical and financial industry need to care about. All software developers need to care about and incorporate the way of thinking and acting you will learn in the next few minutes. As an obvious example why, one only need look at the recent data security breaches at Facebook and data analytics to observe its effect on the broader community. In this video, we are going to examine a number of scenarios software developers often face through the lens of Essence checklists, along with related well-known software questions with cybersecurity twists. What you will learn is how software developers need to be thinking and acting when facing these common situations in order to prevent cybersecurity risks and related problems. So let's get started. The first well-known question with a new cybersecurity twist is, what is the intended purpose of the system to be developed or modified? Experienced software professionals know that before digging in and agreeing on detailed requirements, it is best to first step back and make sure there is agreement with key stakeholders on the purpose of the system and what the system's success means. But a twist to this question from a cybersecurity perspective is, how do we ensure the system is not used for nefarious purposes? It has long been known that the best testers have a mindset that starts with the belief that the system is broken. With this mindset, good testers don't just test for what the system is intended to do, but also for what it is not intended to do. This is a great way for developers to think as well, to help them build a secure system. As a quick example, when you're designing your software to handle a user input, don't assume the human knows what they are doing. Always anticipate the unexpected. This has been referred to as defensive programming, or making sure your software operates securely under unforeseen circumstances. This defensive way of thinking should be a natural part of professional software engineering, especially given the cyber threats we face in today's world. Now, some might object to this way of thinking by saying it is not in the spirit of being agile, and by pointing out that we are giving the developer more things to think about and more work to do, which will add cost and time. This is where I want to explain an important characteristic of Essence checklists and how developers should be using these checklists in making what I call effective decisions with just the right level of agility. You will not find the word cybersecurity anywhere in the Essence checklists. But you will find the words criteria and agreed in multiple places. Now let's look at an example. On the slide, you see in the software system area the checklist architecture, selection, criteria, agreed. You will also find checklists for key architectural characteristics demonstrated, critical interfaces demonstrated, and system performance acceptable. Now let's look at how a software developer should be using these checklists in making effective defensive programming decisions. Part of the demonstration of key architectural characteristics and critical interfaces should include how humans and external systems interface to the system. These demonstrations should be conducted using a tester's mentality to ensure unfriendly humans and unfriendly external systems cannot gain access. From a software developer's perspective, the architecture should provide rules on how the software applications communicate with external systems, including humans, authorized to access the system. Being diligent about following architecture rules is one way software developers can implement defensive programming techniques to help ensure their software is secure. One thing I hope you take away from this video is that the Essence checklists help software practitioners think about the right things and ask the right questions at the right time. They are not check-the-box checklists. Now let me give you another scenario that demonstrates how these checklists are not check-the-box checklists. As developers write and test their code, following the agreed-to architecture rules, they also need to think about performance requirements. If the system can't be operated effectively by humans, they may need to discuss alternative design approaches to meet the stakeholder needs. These discussions should be conducted with personnel responsible for the architecture and in consideration of any potential cybersecurity risks. When addressing performance, often the change needs to be at the architecture level rather than the application. In this way, cybersecurity risks and potential problems are addressed in an effective and agile way. Now, some developers might respond by saying, I don't have control over the architecture. It was developed years ago. I am just making a small software change. In this case, software developers still need to think through the same issues just discussed. If the architecture doesn't adequately address cybersecurity risks, You need to, at a minimum, identify the risk to the appropriate people on your project and agree on an approach to mitigate the risk. Another Essence software system checklist item is buy, build, reuse decisions made. Is the system new or a modification to an existing system? If new, a natural question is, can we purchase software to meet our new requirements or reuse existing software? This question leads to another cybersecurity twist. If the decision is to buy or reuse, how much do you know about the source of the software you are purchasing or reusing? Do you trust the team that developed that software? Will you need to go back to a different organization to maintain it? And if so, is communication open and honest with the developers in that organization? Once you have made your build, buy, reuse decisions, then your team moves forward developing, integrating, and testing the solution. The same questions we asked previously with respect to any different organization's involvement need to also be asked with regard to your own team members. Sometimes there are team members who like to work alone and don't collaborate well. Sometimes this is just because of their style, and other team members learn to live with this. Sometimes it's just because they are an expert in their area and don't want others to get to know what they do for job security. These are not new issues that arise only with cybersecurity concerns. We have known about them for over 50 years. But in today's cyber world, there are new twists to these questions with regard to potential insider threats. Insider threats can thwart the best architecture decisions because insiders are often trusted and can bypass protocols. When a team member is hesitant to share what he or she is doing, or is off doing work that doesn't seem to be focused on the mission of the team, it might just be because the individual is not a good team player. But it also could mean that there is something nefarious going on. Software developers need to be aware of this possibility and how and when to report such concerns to appropriate security personnel. Now, let's move on to another area. We have known for a long time that a good reason to break work down is because it helps team members make more accurate estimates, increasing the likelihood of hitting schedule commitments. But now let's think about what happens from a cybersecurity perspective when you don't sufficiently break the work down. When we don't adequately break the work down, often this leads to discovering that there is more work to do than originally estimated. This means the team member assigned to that work is more likely to have trouble and feel pressure to meet their schedule commitments. This can lead to cutting corners with regard to the agreed way of working, including following the interfacing architecture rules as discussed previously. This in turn can open a door to an unfriendly intruder. One point I hope you are taking away from this video is that even if all the right questions are asked by architects and the right architecture is selected, there is always the possibility that potential cyber vulnerabilities can enter the system at each stage of development, including whenever a developer makes even the smallest change in the code. Now let me switch gears a bit to talk about another subject that often comes up when discussing cybersecurity. How does agile development affect cybersecurity? In 2008, then Secretary of Defense for the US government, Robert Gates, said that we can't keep looking for the 100% solution. More precisely, he said that our conventional programs seek 99% solutions that take years, whereas the wars we are in today require 75% solutions in months. The popularity of the Agile movement has continued to grow for many reasons, including statements like the one just mentioned by Secretary Gates. But how are we making decisions on what 25% can be cut? This brings us to another age-old question. Are the defect levels acceptable? Today, more and more organizations are recognizing that they have to get software delivered fast to stay competitive. And therefore, they can't afford to wait until the system is perfect. But from a cybersecurity perspective, we need to always be asking another question before deciding if a 75% solution is good enough. Do any of the existing defects open up any risks of unauthorized users accessing the system? The point is, even if workarounds to existing defects are acceptable to end users, we need to always be asking if those defects are opening up any cybersecurity vulnerabilities. And often, it is only the software developer that may understand that such vulnerabilities even exist and the potential consequences, because in the end, it is the developer who understands best the code they wrote. What I hope you take away from this video is that in today's cyber Internet of Things world, questions that in the past were only of concern in highly regulated environments should now be of concern to all software professionals. I also hope you take away the fact that the checklists used in this video from the Essence framework are not checklists that can be applied using a check-the-box mentality. These checklists can help software developers ask the right questions, leading to the right discussions with the right people, leading to the best decisions and actions given the team's context. I have included on this final slide a list of references where you can find more information on this topic and my contact information.